Hello, in today's video, we are going to be taking a look at neutralization reactions. So in a neutralization reaction, we will always have an acid and a base that react together to make water and an ionic salt. So when we are writing out our neutralization reactions, we will always first make H2O. Now, the H2O is formed from the hydrogen ion from the acid and the hydroxide ion, which would come from the base, combining to make water. Then you would have your positive ion from the base, negative ion from the acid, and those will combine to produce our ionic salt. Now, when we make the formula for our ionic salt, we do need to check the charges. So if these were my two ions, I would check the charges and crisscross, and that would give me X2, Y3. That ensures that my salt is neutral overall, because then my positive and negative charges would cancel out. And then lastly, then we will need to balance our equation. So we will need our periodic tables for these examples. All right, so our first one is a neutralization reaction. We have our acid and our base, so we recognize that we are a neutralization reaction. Therefore, we must be producing water. The water comes from the hydrogen ions from the acid and the hydroxide ions from the base. That leaves behind the chloride and sodium ions. Now we always do our positive ion first. So we know that sodium makes a +1 charge. We would see that on the periodic table. And we kind of just know it at this point in the year. Chloride makes a -1 charge, so they combine together to make NaCl. Last thing is we would need to balance our equation, and this one works out very lovely because this equation is already balanced. So we would just have coefficients of 1, or we can just leave them blank. All right, in this next example here, I have H2SO4 that shows up on our common acid tables. We recognize that as an acid, and calcium hydroxide. So we should recognize that as a base. So since I have an acid and a base, I know that I'm going to make water. The water comes from the hydrogen ions from the acid, the hydroxide ions from the base. Now I realize that this is unbalanced, but I'm going to take care of that at the end. All right, that leaves behind the sulfate ion and the calcium ion. So I check my charges. Calcium is positive. I look it up on the periodic table, +2 charge. Sulfate, polyatomic ion, and that has a -2 charge. So since I'm +2 and -2, they're going to combine in a 1-to-1 ratio to make CaSO4. Lastly, I do need to balance my equation. All right, so I would cut my reaction in half and count up what I have. So I have a total of 4 H's, 2 from the H2SO4, 2 from the calcium hydroxide, 1 sulfur. Oxygen is 4 plus 2 for a total of 6, and calcium is 1. I count on the other side. I only have 2 H's. So that's something I'm going to have to take care of. 1 sulfur. Oxygen is 1 in the water, 4 in the calcium sulfate for a total of 5, and calcium is 1. So sulfur and calcium are already balanced. Hydrogen is going to be a touch easier to fix. So I know I need to get hydrogen to 4, so I put a 2 in front of water. That changes hydrogen to 4. That also changes those oxygens from water to 2, giving me 6, so now everything is all balanced. And here is our final example. So HNO3 is an acid, CaOH2 is a base. Therefore, they will produce water and an ionic salt. The water comes from the H's from the acid, the OH's from the base. That leaves behind the calcium ion. Calcium has a +2 charge, and the nitrate polyatomic ion. And according to table E, that has a -1 charge. So when I crisscross my charges, I get CaNO3 2. So I need 2 nitrate ions to balance out the +2 from calcium. My final step is balancing the equation. So I cut my reaction in half. Right now, if I have ones in front of everything, I have a total of 3 hydrogens. I only have 1 nitrogen. I have 5 oxygens and 1 calcium. On my product side, I have 2 hydrogens. I have 2 nitrogens. Oxygen would be 1 from water, 6 from the calcium nitrate for a total of 7, and calcium is 1. So the only thing that's all set is calcium. Nitrogen is going to be the easiest thing to fix because that only shows up in one spot on either side. I will need to put a 2 in front of HNO3. That would change those hydrogens to 2, giving me 4. Nitrogen would be 2, which is what I want. And oxygen, 6 here, plus 2 from the calcium hydroxide to give me 8. So my next easiest thing to fix would be water, or would be hydrogen. I'm going to put a 2 in front of water. That gives me 4 hydrogens, which is what I wanted. And it switches just those O's to 2, leaves those at 6, giving me 8, and now everything is balanced. So to summarize, when we are doing an acid-base neutralization, we will make water and an ionic salt. When we are forming our ionic salt, do not forget to check your charges so that you make the proper formula. And then lastly, you'll balance your equation.